Hello everyone and hello Mr. Camera. I hope you all are fine. So today in this class we are going to discuss the problem of linearize a generic tree, right? So when I used to learn data structure, I find the questions of trees very interesting, right? So let's discuss this problem. First of all, we have to know what is the meaning of to linearize a generic tree, right? So let's first learn this. What is the meaning of linearizing? Let's suppose we are having a tree, right, like this. So, Mr. Camera, I hope you know what is a generic tree. So, we know that in a generic tree, we can have a node can have as many children as it can. So, let's suppose this is our generic tree, right? And we have to linearize this, right? So, by linearizing, we mean that each node of this tree should have only one children, right? So after linearizing, this tree will get something like this, right? So we can see that in this tree all nodes are having only one children, right? So this is the tree that we get after linearizing this tree. Now if we notice that, we can see that if we traverse in this linearized tree, this is the post pre-order of this generic tree, that isn't right. So after 10 it will be 20, 50, then 60, 30, 70, 18, 110, 120 and so on. So this is the pre-order. So we have to linearize this tree in such a way that each node will have at most one child, and the traversal of this tree will be the post order traversal of our original generic tree, right? So let's first discuss the approach to find this linearized tree. So we can see that this we can done in the pre-order, right? So first of all, we are having a faith that 10 is having a faith that all its children, that is 10, 20 and 30, will know how to linearize themselves. So 10 is having a faith that it is going to linearize their children is going to linearize themselves, and only 10 have to linearize itself, right? So if we call a node 10, so it will get its children linearized, right? So if we call 10, then all its children already linearized themselves, right? So it will be something like this. So what 10 needs to do then in order to linearize itself, right? So 10 needs to remove its rightmost child, and then 10 have to add this child to the tail of its rightmost child. First, the rightmost child of 10 is 40. 10 has to remove this and to add this at the tail of its second rightmost child, right? Also, after this, 10 have to remove its rightmost child and add it to the tail of its next rightmost child, right? So after this, it will be something like this. So this is what we want, right? So our expectation in this problem is that we are getting a tree that is linearized in the pre-order traversal, and our expectation is that our children is going to linearize itself, and I have to perform these operation in order to linearize myself, right? So let's try to code this. So we know that firstly we have to linearize our children. right? So we are going to apply this function on the children first, right? Linearize first, linearize 10 ask their children to first linearize themselves, and then 10 will linearize itself. Child, right? And then we have to perform our work in post order, right? After this, 10 will get its children linearized, and 10 have to perform the operations in order to linearize itself, right? Now what are the operations? We have to perform, we have firstly to get, we want the tail of this second rightmost child of 10, and then we have to add this rightmost child of 10 to the tail of this, and we have to remove this from the array list of children of 10, right? So we have to start it from size -2, that is the second rightmost child of 10, right? It will go till 0. Now you can see that we want, and we need another function in order to get the tail of this second rightmost child of 10, right? So we need another function, say get tail. Tail should be equal to get tail of the second rightmost child of 10. The second rightmost child is stored at ith position. Since we are starting the loop from node.children.size -2, it will give us the second last element, right? Before this, we can store the last element in a node variable, say temp, right? So let's store the last child of 10, that is the last element in the array list, which is stored at I plus 1. Since I is starting from last second element, so the last element will be at I plus 1. Let's write the code for get tail function. It will return us a node, so the return type will be node. We are passing a node here. So in order to get the tail, think of it as a linked list. 30, 70, 80, 110, 120 and 90. So in linked list, what we did that in order to get the tail, we are taking a node here and we are going to increment this until we get a null, right? So this will increment it until the size of node is 1. When the size of node will become 0, we will return this node, right? So let's write this code. So while node.children.size is 1, we have to increment the node 0. Since the list is on the tree is already linearized, so there will be only one element, so we are taking the index at 0 as 0, right? So when it will go out when there is no children, that is the last node, that will be the tail, right? Our next step is to remove the last rightmost node from the children of 10. or you can say temp, right? And we have to add it to the children of tail. Add temp. So we are removing this temp from the children list of 10 and we are adding this to the tail of to the children list of tail, right? So I think the code is fine. Let's try to run it. We have to declare it here. The spelling of tail will be here. We are using the function as getTail. Let's change this name of the function. So we are getting the expected output. Let's try to submit it. So our code is submitted. So what are we doing? We are only, firstly, we are having a faith that 10 is going to, all the children of 10 is going to linearize themselves, right? And then these are linearized, and then we are starting the for loop from here, that is from node.children.size minus 2, from here, right? We are storing this in some temp variable, right? And we are calling we are getting the tail of this function from getTail function, right? Next we remove this, that is the last element of the array list of children of 10, right? We remove this and we add this to the children list of tail, right? In the same way, here we get the tail from getTail function and we remove this and add this to the children list of tail, right? So in this way our tree will get linearized. If we talk about the time complexity, then the time complexity of this function will be big of n square. Why? Since this for loop is going to visit each and every node of this function is going to take big of n, right? This for loop is going to visit each node of the tree, and in this function, this for loop is also going to visit each node of the tree, so there will be a nested loop. So the time complexity of this function will be big of n square. We can also do is in big of n, that will discuss in the next question. So, but the time complexity for this approach is big of n square, and the space complexity is big of 1. Since we are not using any extra space, so the space complexity is big of 1 only, right? So I hope you enjoyed the session and you got the solution for your problem. Try it out. Thank you so much.